Hi there! For this video, we'll be discussing how to add and subtract radicals. To start this one, we first define what similar and dissimilar radicals are. So we say, it's right here, similar radicals. So we say that two or more radicals are similar if they have one, they have the same index, and two, they have the same radicand. So as an example, if we have cube root of 2 and cube root of 2, these two are similar since the index out here is the same and also the radicand out here is also the same. So these two are a similar radicals. If we have square root of 3 and cube root of 3, these two are not similar since although they have the same radicand, their index, here 3, in here since there's none, this must be 2. So these index are not the same. And also if we have, say, 4th root of 2 and 4th root of 3, although their index are the same, the radicand inside is not the same. So we will use this concept in answering some examples later. Let's have this first example. Let's have 5 square root of 2 plus 2 square root of 2. First, we try to inspect the radicals that they have. In here, square root of 2, square root of 2 are similar radicals. So if we have similar radicals, we can combine these two. How do we do that? What we do is we treat these radicals like variables. So recall that in adding variables, if we have like 5x plus 2x, then their outcome is simply 7x. So we add the coefficients. So for this one, we will have, adding their coefficients, that will be 5 plus 2 square root of 2, or simply 7 square root of 2. Let's have this next example. Let's have 6 cube root of 3 minus 2 cube root of 3 plus 4 cube root of 3, rather square root of 3. Now for this one, observe that the cube root of 3 out here and out here are similar. But this one out here, the radical out here, is not similar to the first two. So we only add or subtract of these two out here. So this one will be equal to 6 minus 2 cube root of 3, and for this one, we simply just copy it up, plus 4 square root of 3. Simplifying, this one is equal to 4 cube root of 3 plus 4 square root of 3. And this one out here is the simplified version of this problem. Let's have this third example. Let's have 2 square root of 1 plus 3 cube root of 1 minus 4. Oops. This should be 4 fourth root of 1 minus 5 fifth root of 1. Now at first, although it might seem that these radicals are not similar since their indices are different, but note that the nth root of 1 is equal to 1 raised to 1 over n, and we know that 1 raised to any number is still equal to 1. So this expression out here can actually be simplified into 2 times 1 plus 3 times 1 minus 4 times 1 minus 5 times 1. Or simply 2 plus 3 minus 4 minus 5, or when simplified, this one is equal to negative 4. And this one is the answer. So be careful when we encounter these types of problem that you might initially assume that these radicals are dissimilar. Let's have this fourth example. Let's have 10 square root of 2 plus the fourth root of 4. Now again, these radicals might seem dissimilar, but note that the fourth root of 4 out here can be written as the fourth root of 2 squared. And this one is equal to 2 squared raised to 1 over 4 by loss of exponents, 2 raised to 2 over 4, or 2 raised to 1 half, which is equal to square root of 2. So this one out here is equal to square root of 2. So we can actually write this one as 10 square root of 2 plus square root of 2. Applying the idea that we had by adding the coefficients, this one is 10 plus 1 square root of 2, or simply 11 square root of 2. So again, when encountering a dissimilar radical, try to explore it first before concluding that it is actually dissimilar. Let's have this fifth example. Let's have square root of 50 plus square root of 32 plus square root of 75 minus the square root of 12. Now, although it might seem dissimilar, the radicals might seem dissimilar at first, note that we can write this one as the square root of 25 times 2 plus the square root of 16 times 2 plus the square root of 75 can be written as square root of 25 times 3 minus the square root of 12 can be written as 4 times 3. By the second law of radical, we can write this one as the square root of 25 times the square root of 2 plus square root of 16 times the square root of 2 plus the square root of 25 times the square root of 3 minus the square root of 4 times the square root of 3. And these out here, we know that these numbers inside are perfect squares. So we can write this one as 5 squared times square root of 2 plus 4 squared times square root of 2 plus square root of 5 squared times square root of 3 minus square root of 2 squared times square root of 3. And from here, we apply the first law of radical, so we can remove out this radical sign out here, and we'll obtain 5 square root of 2 plus 4 square root of 2 plus 5 square root of 3 minus 2 square root of 3. Since we don't have much space, let's clear this one out. And this is what we have so far. Since we can observe that these two are similar and these two are similar as well, we can write this one as 5 plus 4 square root of 2 plus 5 minus 2 square root of 3. Simplifying, we obtain 9 square root of 2 plus 3 square root of 3. And that is the answer. So this type of example is what you'll usually see in most problems. So it is really important to first simplify. Learn how to simplify radicals before you add. Let's have this one last example, and let's make this a bit more challenging. Let's have the square root of x cubed y c raised to 5 plus the square root of x y raised to 7 z raised to 3 plus the square root of x raised to 9 y raised to 5 and z. So this time we'll have some variables, and again the key is to simplify each variables or radicals first. Since we have here square roots, we'll try to convert the radicands inside to perfect squares. So in the first one, we can write this one as x squared times x times y times z raised to 4 times z. So basically I applied laws of exponents in this one and this one. For the next one, we can write this as x times y raised to 6 times y times z squared times z. Lastly, for the last radical, we can write this one as x raised to 8 times x times y raised to 4 times y. So there's no more space, so this one. And times z. Now from here, observe that this one out here can be written as z squared squared. So we'll write this one as z squared squared. Also, this one is equal to y cubed squared. So we'll write this one out here as y cubed squared. Then lastly, in the last radical, we have here x raised to 8 and y raised to 4, which are both equal to, the first one is equal to x raised to 4 squared, and the second one is equal to y squared squared. So this one, let's use a smaller pen to be able to write it. This one is equal to x raised to 4 squared. And the one out here is equal to y squared squared. Well, by the second law of radicals, we know that we can extract out the perfect squares in each radical. So in the first, we'll have here the square root of x squared times the square root of z squared squared times square root of xyz plus the square root of y cubed squared times the square root of z squared times the square root of xyz, and the last one we have here square root of x raised to 4 squared times square root of y squared squared times square root of xyz. So apologies for not being able to write it properly, but in this step we'll apply the first law. Since we have a square here and a square root out here, we can remove the radical sign out here, out here, out here, out here, out here, and out. So basically we applied some laws of radicals. So this one now is equal to x times z squared square root of xyz plus y cubed z, y cubed z times square root of xyz plus x raised to 4 y squared times square root of xyz. And this one is actually the answer already, but we can also write this one as x z squared plus y cubed z plus x raised to 4 y squared times square root of xyz. How were we able to do that? It's because note that the radicals left are similar. So basically, we can add their coefficients. And we obtain this one as our final answer. This whole expression. Before I end this one, here is an exercise that you can work. Let's have the square root of 2 squared plus 4x plus 2 plus the square root of 8x squared plus 16x plus 8. So this might seem tricky, but you can try to apply some factoring methods to solve this one. And so that's it for this video. It's quite a long one, but I'll make sure to put the timestamps down there so you can quickly skip to what exercise or example you want to work. So feel free to comment down below your answer and solution to this exercise out. So that's it, and that is all for this video.